dy dx equals 3xy over x squared plus y squared. So it's a homogeneous equation, so let y equal vx then. Or in other words, v equals y over x. There. So in that case, if we divide by x squared top and bottom, we'll have 3y over x on the top, which is a v. And then we'll have divide by x squared on the bottom, we get a 1 plus v squared. That's what we've got. Let's get dy dx as well then. It's a product rule, so we use the product rule for differentiation. The u term is v here, so it's v times 1 plus x times this thing differentiated, which is dv dx. So we end up with v plus x dv dx is the product rule. So we've got that. Now substitution then gives. So what have we got then? We've got dy dx, which is v plus x. Dv dx is equal to 3v over 1 plus v squared. There we go. So now we need to move the v across before we separate the variables. So that implies then x dv dx is equal to 3v over the 1 plus v squared minus v, and the way I'm going to write v in this instance is 1 plus v squared over the 1 plus v squared, like so. Now we can expand that bracket on top here. We've got the same denominator, which is 1 plus v squared. And on the top we've got 3v take v, which is 2v. And then we've got a minus v cubed, haven't we? Okay, so now we can separate the variables and integrate. So separating the variables gives, let's see what we've got then. We've got the dv can stay where it is. The dx come up the other side. The x moves from times down to divide on the other side. We've got the integral there. This moves from divide up to times, so it's 1 plus v squared on top. And underneath, we've got a v, which we can bring outside a bracket, and a 2 minus v squared. Okay, so we need to use partial fractions here, don't we, to look at this. So let's do that as a subproblem. So I'll just change the color, and I'll do the subproblem as a partial fraction. So here, I'll write it as v squared plus 1 over, yeah, I'll leave it as it is at the moment. 2 minus v squared is equal to, it will be a over v. It's a proper fraction, isn't it? Because this is of order 2, this is of order 3, plus b v plus c, isn't it? Over 2 minus v squared. That's what we need to write for partial fractions. That's the rules. So multiply by the denominator then. That gives v squared plus 1, because we need to work out these constants. A cross multiply 2 minus v squared plus bv plus c, all times by v. Put in v as 0 as the first one. And we'll get rid of the second terms here, and we'll just get a. So you get 1 equals 2a, don't you? So a is a half. So that's good. Now what should we put in? We could put v as root 2, or we could do something else. There's a v squared here and a v squared. So the v squared looks good. Let's worry about that. Coefficient, there's a 1 here. There's a minus av squared here. And there's a plus b there. So that tells us what b is. B is equal to, reading from right to left, 1 plus a. And a is a half. So that's equal to 3 over 2. There's b. Now we need to worry about c. So how are we going to get c? We've got a and b. C is working with v, so let's write down the coefficient in v's. There's none of them here. There's none of them here. Is there? No. And there's only a cv there. So that tells us that c is equal to 0 then, doesn't it? Okay, that's good. So now we know a and b. A is a half, b is 3 over 2. We can write down our original problem then. Instead of writing this stuff here, we can write a is a half and b is 3 over 2. Okay, so bear that in mind then when we're doing the integral. So let's finish with the subproblem. And we can write now, so our integral on the left-hand side can be replaced by this stuff here. A is a half, so it's 1 over 2v. and then b was 3 over 2, wasn't it? So it's plus 3 v over 2 minus v squared. There we go. dv is equal to, and the integral of 1 over x is log n x, so we might as well put that in now, plus k. So that's what we've got. So it's one more step now. So here this is half log nv. This is plus, now we're going to have ln of 2 minus v squared, and we've got to worry about the juggling the constant, haven't we? This is log of something. Log of something differentiates to 1 over something, so that's taken care of that there. Multiplied by the something differentiated, which will be a minus 2v. And we've got, the v's are taken care of then. We've got a minus 2. So to have a 2 underneath, we'll need a 4 on underneath, and we'll need a 3 there. And this needs to change to a minus. So let's put a minus in. And let's double check that now, because it should be easy to double check. That's what we think it is. And that will equal ln x plus k. Right, let's check this then. 1 over this is that thing there. Then minus 2v will come out when you differentiate the something, times by this. That will be plus 2v times 3 over 4 will be 3v over 2, which is what we've got. So I think we're reasonably happy with that. Now, at long last, we can put the v in. It's ln y over x, half ln y over x minus 3/4, ln of 2 minus, and we can write y over x with both squared when we simplify that, is equal to ln x plus k. There we go.